Welcome, tech enthusiasts and AI aficionados, to another captivating episode of our deep dive series into the latest breakthroughs in machine learning and artificial intelligence. Today, we're unraveling the intricate and fascinating papers released on July 19th by HuggingFace. In this episode, we'll explore cutting-edge innovations and transformative research that are pushing the boundaries of what's possible in AI. From novel models and algorithms to groundbreaking applications and theoretical advancements, these papers represent the pinnacle of current AI research. Stay tuned as we dissect each paper, offering detailed insights and expert commentary to help you understand the complexities and implications of these advancements. Whether you're a seasoned professional or a curious learner, this video will provide you with a comprehensive overview of the state of the art in AI. Let's embark on this intellectual journey together and discover how these new developments are set to shape the future of technology. Scaling laws with vocabulary. Larger models deserve larger vocabularies. Introduction. The research addresses the critical yet often neglected role of vocabulary size in the performance of large language models (LLMs). Traditionally, scaling laws focus on model parameters and training data size, overlooking how vocabulary size impacts these models. This study aims to fill this gap by investigating the optimal vocabulary size for various LLMs and proposing methods to determine the compute optimal vocabulary size. Key concepts. Scaling laws, empirical formulas that predict model performance based on computing operations flops, model parameters, and training data size. Vocabulary size, the number of unique tokens that a model can recognize and process. The study posits that larger models benefit from larger vocabularies, enhancing their ability to handle diverse and complex language constructs. Methodology. The researchers proposed 3 complementary approaches to predict the optimal vocabulary size. Isoflops analysis models with varying vocabulary sizes are trained, and power laws are fitted to determine the optimal vocabulary size for a given computational budget. Derivative estimation. The optimal vocabulary size is estimated by calculating the derivative of flops with respect to the vocabulary size and finding the zero solution. Parametric fit of loss function. Existing scaling laws are modified to include vocabulary size, and the resulting formula is used to predict loss based on non-vocabulary parameters, vocabulary parameters, and training data. All findings and implications. Optimal vocabulary size. Larger models necessitate larger vocabularies. For example, the optimal vocabulary size for Llama 270 billion should be 216K, significantly larger than its current size of 32K. This finding implies that many existing models use suboptimal vocabulary sizes. Validation. Empirical validation showed that models trained with the predicted optimal vocabulary size consistently outperform those with smaller, commonly used vocabulary sizes. For instance, increasing the vocabulary size from 32K to 43K improved performance on the ARC challenge task without additional flops. Model efficiency. Adjusting vocabulary size can significantly enhance model performance and efficiency. This adjustment is crucial for optimizing the allocation of computational resources during model training. Trade-offs and practical implementation. While larger vocabularies improve model performance, they also increase computational demands during both training and inference. The study emphasizes the importance of balancing these trade-offs to achieve optimal model configurations. Detailed analysis. Impact on training time and resources. Larger vocabularies require more computational resources, but the performance gains justify the increased investment, especially for high-capacity models. Generalization to unseen data. Models with optimal vocabulary sizes demonstrate better generalization on unseen data, as they can capture a broader range of linguistic patterns and nuances. Downstream task performance. The study validated the predictions on various downstream tasks, showing significant performance improvements across tasks like ARC Challenge, HelloSwag, and others. Multilingual models. The proposed methods can be adapted for multilingual models, though the optimal vocabulary sizes may vary based on language-specific characteristics. Interpretability of outputs. Larger vocabularies can enhance the interpretability of model outputs by providing more granular and accurate token representations. Limitations and drawbacks. Increasing vocabulary size can lead to computational inefficiencies and challenges in managing rare tokens, which require careful handling to prevent overfitting. Future research directions. Rare tokens. Further research is needed to develop strategies for effectively incorporating rare tokens without compromising model performance. New architectures and training techniques. As new architectures and training techniques emerge, the relationship between vocabulary size and model performance may evolve, necessitating ongoing investigation. Data scarcity and overtraining, exploring the impact of data constraints and excessive training data on optimal vocabulary size can provide insights into more efficient model training practices. Conclusion. The study underscores the critical role of vocabulary size in scaling LLMs and proposes robust methods for predicting and implementing the optimal size. By integrating these findings into current LLM training pipelines, researchers and practitioners can achieve more efficient and powerful language models. The paper introduces a novel approach to improving language models by scaling the size of the data store used at inference time. Traditional scaling laws focus on the amount of training data and the number of parameters in the model. This research highlights the benefits of increasing the data store size for retrieval-based language models, showing that it enhances performance across various tasks without saturation. The study constructs a 1.4 trillion token data store named Massivids, the largest open-source data store for retrieval-based language models, and designs an efficient pipeline to facilitate computationally accessible research on data store scaling. Retrieval-based language models access external data through a data store during inference, retrieving relevant information to improve output quality. Previous research focused on single-source data stores like Wikipedia, which are limited in size and domain diversity. The largest proprietary data store prior to this study was Retro, with 1.75 trillion tokens, but it was not open-sourced and had limited evaluation. Massivids includes both general web data and domain-specific data, totaling 1.4 trillion tokens. Domain-specific data sources include books, scientific papers, encyclopedic articles, community Q&A forums, code repositories, mathematical texts, and biomedical articles. General web data comes from multiple Common Crawl snapshots and C4. To manage the computational cost of constructing and evaluating large data stores, the study introduces an efficient pipeline. Indexing. Distributed indexing of documents to parallelize the process. Document retrieval. Parallel retrieval of top K documents from each domain-specific shard. Domain merging. Merging top K documents from target domains. Data filtering and re-ranking. Applying data quality filters and re-ranking documents to refine retrieval quality. Subsampling. Reducing the size of the data store by random subsampling. The study uses various model families including Llama 2, Llama 3, Pythia, and Ulmo. Evaluations are conducted on both language modeling and downstream tasks like general knowledge QA, domain-specialized QA, and reasoning tasks. Key metrics include perplexity for language modeling and accuracy for downstream tasks. Key findings. Data store scaling significantly reduces perplexity, improving performance without saturation. Small models with large data stores can outperform larger models without retrieval. Data store scaling enhances performance in knowledge-intensive tasks, with smaller models surpassing larger non-retrieval models. The degree of improvement varies by task. Retrieval-based language models offer superior performance for the same training compute budget, indicating that storing knowledge in a data store is more efficient than encoding it in model parameters. Improved retrieval quality and data filtering further boost performance. The study highlights the importance of both data composition and retrieval methods. Analysis. Massivids outperforms single-domain data stores, demonstrating the benefits of a diverse and broad data store. Better re-ranking methods, such as using a cross-encoder model, can significantly enhance retrieval performance. Effective decontamination is crucial for accurate evaluation, especially in retrieval-based models that might retrieve verbatim test data. Limitations and future work. The study acknowledges limitations in computational resources, affecting the scope of experiments. Future work should explore extending massive with higher quality data sources, improving retrievers for reasoning-heavy tasks, and evaluating more diverse downstream tasks like long-form generation and mathematical reasoning. Conclusion. This research establishes the importance of data store size in retrieval-based language models, showing that larger data stores lead to better performance and efficiency. The open sourcing of Massivids and the associated pipeline aims to encourage further exploration and development in this field. The paper titled Shape of Motion 4D Reconstruction from a single video addresses the challenge of reconstructing dynamic scenes with explicit, full-sequence long 3D motion from single videos. Previous methods in this domain have faced limitations, such as reliance on templates, effectiveness only in quasi-static scenes, or inability to model 3D motion explicitly. The authors propose a method leveraging two key insights. First, they exploit the low-dimensional structure of 3D motion by representing scene motion with a compact set of C3 motion bases. Each point's motion is expressed as a linear combination of these bases, facilitating the decomposition of the scene into multiple rigidly moving groups. Second, they utilize data-driven priors, including monocular depth maps and long-range 2D tracks, to consolidate noisy supervisory signals into a globally consistent representation of the dynamic scene. The proposed method represents the dynamic scene as a set of persistent 3D Gaussians, with motion across the video expressed as a combination of, say, 3 motion bases. This approach allows for long-range 3D tracking, enabling the recovery of persistent 3D trajectories over the entire video, and novel view synthesis, rendering moving scene elements at fixed viewpoints with different moments in time. In the representation, the appearance and geometry of dynamic scene contents are modeled with 3D Gaussians defined in a canonical frame. The projections of these Gaussians in the image plane are parameterized and rasterized into RGB images and depth maps via alpha compositing, a fully differentiable process that enables direct optimization of 3D Gaussian parameters. To model the full-length motion trajectories of dynamic scene elements, a set of compact C3 motion bases is used. Each 3D Gaussian's motion is a weighted combination of these bases, ensuring smooth and low-dimensional motion trajectories. The optimization process involves several steps. First, the canonical frame is selected, and Gaussian means and motion bases are initialized using k-means clustering on noisy 3D tracks. During training, dynamic Gaussians are supervised with reconstruction loss, matching per frame pixelized color, depth, and masks inputs, and correspondence consistency loss, supervising the motion of Gaussians between frames. Additional constraints include a distance-preserving loss to maintain consistency in 3D space. Implementation details include obtaining camera parameters for in-the-wild videos using UniDepth for intrinsics and metric depth maps, and Droid Slam for camera poses. The optimization is performed using the Atom Optimizer, with specific settings for the number of dynamic and static Gaussians and training duration. The method is evaluated on tasks such as long-range 3D point tracking, long-range 2D point tracking, and novel view synthesis, using datasets like iPhone and Kubrick. The proposed method outperforms baselines in both synthetic and real-world datasets, achieving significant improvements in tracking accuracy and novel view synthesis quality. The iPhone dataset, containing sequences of casual captures of real-world scenes with comprehensive annotations for 3D tracking and novel view synthesis evaluation, shows that the proposed method significantly improves performance over baselines in all tasks, particularly in scenarios with significant scene motion. The Kubrick Movie F dataset, containing synthetic scenes with complex motions, demonstrates the proposed method's better long-range 3D point tracking accuracy than baselines, proving its effectiveness in handling dynamic scenes with multiple moving objects. Ablation studies validate the choices of motion representation and training strategies. The C3 motion basis parameterization and the use of 2D track supervision are crucial for achieving high 3D tracking accuracy. Despite its promising results, the method has some limitations. It requires per scene test time optimization and accurate camera parameters, which can limit its applicability in certain scenarios. Additionally, it relies on user input for generating masks of moving objects. In conclusion, the paper presents a novel method for joint long-range 3D tracking and novel view synthesis from monocular videos. The dynamic scene elements are modeled with a global set of 3D Gaussians whose full-length 3D motion trajectories are parameterized with C3 motion bases. By consolidating noisy data-driven observations into a consistent estimate of scene geometry and motion, the method significantly improves performance over prior state-of-the-art methods. Imagine you could walk through any city, experiencing the streets as if you were there in real life. That's what the researchers behind Streetscapes' large-scale consistent street view generation using autoregressive video diffusion have created. Their method allows for the generation of long sequences of street views through vast synthetic urban environments. What's even more impressive is that these virtual streetscapes can be tailored by simple text inputs, like the name of a city or specific weather conditions, all guided by a detailed map. The problem with current technologies is they can make short video clips or single 3D objects, but struggle with creating larger, coherent scenes. This research breaks new ground by generating entire city blocks while maintaining high visual quality and consistency over long distances. They achieved this by combining recent advancements in video diffusion models with an innovative autoregressive framework, ensuring the cityscape remains realistic as the virtual camera moves through it. Choosing the right inputs and outputs was crucial. Instead of relying only on text, which can be imprecise, they use a combination of street maps and height maps. This allows for detailed control over the generated scenes. The The outputs aren't just random images but coherent sequences that look like they were filmed in a real city. To ensure everything aligns correctly, they use a G-buffer, which translates map information into screen space. Training the system required extensive real-world data. The researchers used images from Google Street View, covering major cities like Paris, London, Barcelona, and New York City. These images provided not just visuals but also metadata like camera positions, grounding the generated scenes in reality. However, the maps were often coarse and imperfectly aligned, so the system had to be robust enough to handle these imperfections. To create these realistic streetscapes, the system first learns to generate pairs of images from random noise using a diffusion process. It then expands this to generate long sequences with an autoregressive method. This means it generates one frame at a time, building on the previous frame to ensure consistency and realism. They also use a technique called temporal imputation, which adds noise during generation to smooth out any inconsistencies. The results are remarkable. When compared to other state-of-the-art methods, their system consistently produced more realistic and higher quality images over longer sequences. For example, against a method called infinicity, their results were noticeably more detailed and natural-looking. They measured quality using metrics like FIDE-KID, which compared generated images to real ones. One of the most exciting aspects of this technology is its flexibility. You can generate streetscapes with different styles and conditions, like a sunny day in New York or a snowy street in Paris, just by changing the text input. The system can even mix styles, creating a Parisian street that looks like it's in New York, complete with iconic details from both cities. In summary, this research represents a significant advancement in visual content generation. It opens up new possibilities for creating large-scale, realistic urban environments, useful in video games and virtual reality. The system's ability to maintain high quality over long sequences and its flexible control options make it a powerful tool for generating immersive, realistic cityscapes. Understanding reference policies and direct preference optimization. Direct preference optimization (DPO) is a powerful technique used for fine-tuning large language models (LLMs). In this study, researchers delve into an underexplored aspect of DPO, its reliance on reference models, which are crucial as they set an upper limit on DPO's effectiveness. The study tackles three pivotal questions: the optimal strength of the KL divergence constraint in DPO, the necessity of reference policies for instruction fine-tuning, and whether stronger reference policies enhance DPO's performance. The findings reveal that DPO is highly sensitive to the strength of the KL divergence constraint, that reference policies help stabilize model behavior, and that stronger reference policies can improve performance, but only when they are compatible with the model being fine-tuned. The paper begins by addressing the limitations of the standard supervised fine-tuning SFT algorithm typically used for LMS. Advanced training algorithms such as DPO and contrastive learning aim to enable LMs to differentiate the quality of various candidate outputs and generate more preferred results. DPO stands out because of its connection with reinforcement learning RL. Specifically, an LLM trained under the KL-constrained RL framework implicitly learns a reward model, which is then used in DPO's training objective. The reward function in DPO, however, presents a challenge. There is often a discrepancy between the predicted reward and the actual learned distribution. This means that the fine-tuned model cannot deviate arbitrarily from the reference model due to the KL divergence constraint. This highlights DPO's dependency on the reference model or policy, which is usually instantiated by the SFT model. Instruction fine-tuning aims to align pre-trained language models with user intentions. The methods used for this include standard SFT RL methods like proximal policy optimization and reward-based training methods such as DPO. These methods leverage human feedback in the form of rewards assigned to various candidate outputs, enabling a more effective alignment of LMS with human preferences. In the first research question, the study examines the optimal strength of the KL divergence constraint in DPO. This constraint is crucial because it controls the trade-off between maximizing the reward and minimizing the deviation from the reference policy. The results indicate that a smaller KL constraint generally leads to better performance until it becomes too small, at which point performance begins to degrade. This sensitivity is explained by the need for the fine-tuned model to deviate from the reference model while maintaining necessary regularization. The second research question investigates whether the reference policy is necessary for effective preference learning. The study explores two alternative training objectives using the posterior probability and the likelihood function as reward functions. The findings show that while these alternative approaches can improve the original SFT model's performance, they do not outperform DPO. Furthermore, the reference policy helps stabilize model behavior, preventing the model from overfitting to human annotators' preference for more verbose outputs. The third research question looks into whether DPO benefits from stronger reference policies. By employing 2 more capable LLMs as reference models, the study finds that stronger reference models can improve performance, but only when they are compatible with the fine-tuned model. This raises important questions about the compatibility of the reference model with the model being fine-tuned in DPO, suggesting the need for future research to analyze and measure their intrinsic similarity. The study also includes a detailed token-level analysis. It reveals that DPO fine-tuning leads to a decrease in token probabilities, with a small portion of tokens receiving significantly different probabilities. Notably, a smaller KL constraint results in a larger difference for the end-of-sequence EOS token, leading to longer outputs and highlighting a limitation of the sequence-level KL constraint in preventing extreme token-level differences. In conclusion, the paper emphasizes the critical role of reference policies in DPO. It highlights best practices, such as using a smaller yet sufficiently strong constraint to improve performance and employing a stronger reference policy that is compatible with the model to be fine-tuned. The study calls for more theoretical analysis to understand the relationship between the reference policy and DPO training performance and dynamics, as well as the need for analytical tools to measure the compatibility of reference models with fine-tuned models. The evaluations primarily use the Alpha-Keval 2 benchmark, which, while generally effective, has some limitations such as low self-consistency rates and predictions, and a preference for the LM's own outputs. Human evaluations, though not performed in the study due to cost constraints, are acknowledged as important for achieving more faithful evaluation results. This paper sheds light on the intricacies of DPO and its dependence on reference policies, providing valuable insights and laying the groundwork for future research in this area. Scaling Granite code models to 128K context. This paper introduces IBM's long-context Granite code models, which extend the effective context window to 128,000 tokens. This achievement is made possible through a lightweight continual pre-training process. The process gradually increases the rope base frequency and uses repository-level file packing with length upsampled long context data. Additionally, instruction-tuned models with long context support are developed by further fine-tuning these base models on both short and long context instruction response pairs. The results show significant improvements on long context tasks without noticeable performance drops on regular code completion benchmarks, such as Humanival. All long context Granite models are released under an Apache 2.0 license for research and commercial use. Introduction. With the rise of repository-level coding tasks and advanced software development agents, having a long context length is crucial for code language models. While many proprietary models like GPT-4 support very long contexts, most open-source models have shorter limits, making them less practical for real-world use. This paper presents the Granite 3 billion and 8 billion code models, which support context lengths up to 128,000 tokens. The extension involves continually pre-training the base models with a repository-level code corpus and upsampled long context repositories, followed by instruction tuning on a mix of short and long context instruction data. What is ROPE and how does it work? ROPE, which stands for Rotary Position Embedding, is a technique used in transformer models to encode positional information of tokens. Unlike absolute position embeddings, which assign a unique embedding to each position, ROPE uses a trigonometric function to encode the positions, enabling the model to handle sequences of varying lengths more efficiently. How ROPE works. ROPE modifies the self-attention mechanism in transformers by introducing rotary position encodings to the input token embeddings. These encodings rotate the token vectors in a multi-dimensional space, allowing the model to capture the relative positions of tokens more effectively. The ROPE mechanism can be broken down into the following steps. Encoding positions ROPE uses sine and cosine functions of different frequencies to encode positions. Each dimension of the token embedding is associated with a different frequency. 2. Rotary transformation. The token embeddings are transformed by rotating them in the embedding space according to their positions. This rotation depends on the position of the token and the specific frequency associated with each dimension. 3. Attention calculation. The self-attention mechanism then uses these position-encoded embeddings to compute attention scores, which allows the model to understand the relative positions of tokens within the context window. By encoding positions in this manner, Rope enables transformers to scale to much longer context windows without losing the ability to capture the relative positions of tokens effectively. Long context modeling. Continual pre-training. The base models are continually pre-trained using sequence parallelism, which involves gradually increasing the rope-based frequency without relying on sparse or linear attention. This training uses the original data with repository-level file packing and per-language context length upsampling. The focus is on languages like Python, C, Go, Java, JavaScript, and TypeScript. This process involves analyzing file imports to create a dependency graph, prioritizing semantic relationships, and organizing files accordingly. Longer document sequences are oversampled to improve training quality. The rope-based frequency is adjusted to support contexts up to 128,000 tokens. Training is done progressively, optimizing parameters at each step, using data parallelism and flash attention to up to 64,000 tokens, and then ring attention to reach 128,000 tokens. Instruction tuning. Instruction tune models are created using a mix of permissively licensed data and synthetically generated datasets for long context problems. Long context instruction data is generated by bootstrapping pre-training data and creating multi-turn datasets from repository-level file-packed documents. This involves parsing documents into classes, methods, and functions, generating instructions and explanations based on documentation. The goal is to enhance long context capabilities without sacrificing performance on short context tasks. A multi-turn loss mask is used during training, with specific parameters ensuring the model learns effectively from both short and long context data. Results. Benchmarks. Long code completion (LCC). This benchmark tests the model's ability to predict the next line of code from long repository-based contexts. The dataset is rebalanced for equal representation across different context lengths. Repo-bench similar to LCC, focusing on long context code completion. The dataset is adjusted based on the starcoder tokenizer. RepoCode. This advanced test evaluates long context code understanding and retrieval, where models find functions in a long context based on descriptions. Key retrieval tests the model's ability to find and execute a Python function within syntactically correct Python code. Humaneval extends the Humaneval benchmark to multiple programming languages, testing generation, explanation, and fixing tasks. Base model evaluations. The Granite 3B 8 billion models show significant performance improvements on LCC and Repo-bench benchmarks across all context lengths, demonstrating the effectiveness of long context scaling. Retrieval performance on RepoCode benchmark also shows significant improvements, especially for Python, with long context models achieving high retrieval accuracy compared to short context versions. Instruct model evaluations. Long context instruct models outperform their short context counterparts on the RepoCode benchmark across different similarity thresholds. Synthetic benchmarks for key retrieval also show strong performance for long context models, indicating improved long context capabilities without significant degradation in short context tasks. Short context evaluations. Long context models show minimal performance degradation on short context benchmarks like Humaneval, with some improvements in Humaneval performance for instruction-tuned models. This improvement is attributed to the new synthetic data added during instruction tuning. Conclusion. The long context Granite code models 3 billion and 8 billion effectively support context lengths up to 128,000 tokens, demonstrating superior performance on long context tasks without significantly affecting short context capabilities. The paper emphasizes the potential for further extending context lengths and reducing computational complexity in future models. Continuous updates to these models are planned to enhance their performance and capabilities. Benchmarking trustworthiness of multimodal large language models at comprehensive study. Hello, today we'll explore a comprehensive study on the trustworthiness of multimodal large language models, or LLMs for short. These are advanced AI systems that can understand and generate both text and images. Despite their impressive capabilities, there are significant challenges in ensuring they are trustworthy. This study, called Multitrust, evaluates these models across 5 key aspects: truthfulness, safety, robustness, fairness, and privacy. Background. LLMs are a step towards what many call artificial general intelligence. They combine language understanding with the ability to process other types of data, like images. This makes them very powerful but also introduces new risks. Current evaluations of these models often miss out on a complete picture of their trustworthiness which is what this study aims to address. Multi-trust framework. So what is multi-trust? It's a benchmark designed to thoroughly assess the trustworthiness of LLMs. It looks at 5 main aspects. Truthfulness: does the model provide accurate information? Safety: can it avoid harmful or illegal outputs? Robustness: how well does it handle unexpected or tricky inputs? Fairness: does it treat all user groups equally? Privacy: can it protect personal information? To evaluate these, the study includes 32 tasks using specially curated datasets. Evaluated models. The study evaluated 21 different LLMs, including both proprietary models like GPT-4v and Claude 3, and open source models. These were chosen to cover a wide range of architectures and training techniques. Key findings. Now, let's talk about the findings. Truthfulness: the models do well on general tasks like identifying objects, but struggle with more complex ones like understanding visual illusions. They also tend to get confused by misleading inputs. Safety: proprietary models are generally better at avoiding harmful outputs. For example, they refuse to describe inappropriate images more often than open source models. However, many models can be tricked into providing dangerous information through clever prompts. Robustness: LLMs are quite vulnerable to adversarial attacks. This means their performance can drop significantly when they encounter unexpected or manipulated inputs. Fairness: the models show varying degrees of sensitivity to different types of bias. For example, they may be more prone to age-related stereotypes than to those related to gender or race. Privacy: while the models can generally recognize private information, they often fail to protect it adequately, especially when dealing with complex scenarios involving both text and images. Key findings and their implications. 1. Truthfulness: the study found that while LLMs excel in basic tasks such as object recognition, they struggle with more nuanced tasks requiring fine-grained understanding, like identifying visual illusions. This indicates that while these models are good at straightforward perception, their deeper cognitive abilities are limited. This gap can lead to misinformation, especially in critical applications like healthcare or education, where accurate information is paramount. For instance, if an MLLM is used in a medical setting to assist with diagnoses based on visual data, any inherent deficiency in accurately understanding complex images could lead to incorrect diagnoses, potentially causing harm. Addressing this requires enhancing the model's training with more diverse and challenging datasets that push their perceptual and reasoning boundaries. 2. Safety: safety is a major concern as MLMs are increasingly integrated into applications with direct human interaction. The study highlights that proprietary models have stronger safety measures compared to open source models. Proprietary models like GPT-4v and Claude 3 have safety protocols that prevent them from generating harmful outputs, such as refusing to describe NSFW content or resisting jailbreaking attempts. However, many open source models still fall prey to sophisticated prompts designed to elicit dangerous or illegal responses. This vulnerability poses significant risks, especially as these models become more prevalent in consumer applications like chatbots or content generation tools. Developers need to incorporate more robust safety mechanisms, such as advanced filtering techniques and continuous monitoring for harmful outputs. Additionally, creating a standardized set of safety guidelines and benchmarks can help in maintaining consistent safety guidelines and benchmarks can help in maintaining consistent safety levels across different models. 3. Robustness: the robustness of LLMs is another critical aspect, particularly their ability to handle adversarial attacks. These models are highly susceptible to adversarial examples, where slight modifications to input data can lead to significant performance drops. This is a well-known issue in deep learning models, but is exacerbated in multimodal models due to the complexity of integrating different data types. For example, an adversarial attack could involve subtle changes to an image that the model misinterprets, leading to incorrect outputs. This is particularly concerning for applications in security or autonomous systems, where robustness is essential. Improving robustness requires developing better defense mechanisms against adversarial attacks, such as adversarial training, which involves exposing models to adversarial examples during training to enhance their resilience. 4. Fairness: the study reveals that LLMs exhibit varying levels of sensitivity to different types of biases, such as those related to age, gender, or race. This is a significant issue because biased outputs can perpetuate stereotypes and unfair treatment of certain groups. For instance, if an MLLM is used in hiring processes and exhibits bias towards certain demographic groups, it could lead to discriminatory hiring practices. Addressing fairness involves ensuring that the training data is diverse and representative of all user groups. Moreover, implementing techniques such as bias detection and mitigation during the model training process can help reduce these biases. Regular audits of the model's outputs can also identify and address bias-related issues proactively. 5. Privacy protection is critical, especially as these models handle increasing amounts of personal data. The study shows that while models can recognize private information, they often fail to protect it adequately in complex scenarios. This can lead to privacy breaches, which are particularly concerning in sectors like finance or healthcare, where sensitive information is prevalent. Enhancing privacy protection involves implementing stricter data handling and anonymization techniques. Additionally, incorporating privacy by design principles during the model development process can ensure that privacy considerations are integrated into the model's architecture and functioning from the outset. Developing clear privacy policies and user consent mechanisms can also help in maintaining user trust. Future directions and potential solutions. To mitigate these risks and enhance the trustworthiness of LLMs, several strategies can be considered. 1. Drawing lessons from LMS, since many methods have been proposed to improve the performance and alignment of LLMs, such as Retrieval-Augmented Generation RAG and Reinforcement Learning from Human Feedback RLHF. These techniques can be adapted for LLMs to improve their overall performance and alignment. For instance, RAG can help in providing more accurate and relevant information by incorporating external knowledge sources. 2. Expanding focus in multimodal training. Current training approaches primarily enhance multimodal capabilities by focusing on tasks like optical character recognition, OCR, and image classification. However, there is a need to focus on preserving the alignment of base LLMs during multimodal training. This involves ensuring that the model's understanding and reasoning capabilities are not compromised when integrating different modalities. 3. Dynamic evaluation environments. The static nature of current evaluation benchmarks limits their effectiveness in assessing the model's trustworthiness in real-world scenarios. Adopting dynamic evaluation environments, where models are tested in continuously changing and challenging conditions, can provide a more comprehensive assessment. For example, creating simulated environments that mimic real-world interactions can help identify and address potential vulnerabilities. 4. Community collaboration and open research. Encouraging collaboration within the research community and promoting open research can lead to the development of more robust and trustworthy models. Sharing data sets, evaluation benchmarks, and best practices can help in collectively addressing the challenges faced by LLMs. Open research initiatives can also facilitate transparency and accountability in the development and deployment of these models. 5. Continuous monitoring and feedback mechanisms. Implementing continuous monitoring and feedback mechanisms can help in identifying and mitigating risks as they arise. This involves setting up systems that track the model's performance and behavior in real time and provide feedback for continuous improvement. User feedback can also play a crucial role in identifying issues related to trustworthiness and guiding further enhancements. In conclusion, the Multi-Trust Benchmark provides a comprehensive framework for evaluating the trustworthiness of LLMs. The study reveals significant gaps and risks, highlighting the need for more advanced methodologies and continuous research to ensure these models are safe, reliable, and fair. By addressing these challenges through collaborative efforts and innovative solutions, we can enhance the trustworthiness of LLMs and harness their full potential for positive societal impact. Attention: Overflow language model input blur during long context missing items recommendation. Analysis. Transformer models face inherent challenges in managing long context inputs, notably the issue of attention overflow. This occurs because models need to attend to all input items simultaneously to prevent repetition, a task that becomes increasingly difficult as the number of items grows. In the task of missing item prediction, a transformer model constructs a latent representation of the missing item while predicting the next token. This process is straightforward for small item sets, as indicated by high accuracy in missing number prediction tasks with fewer than 128 items. However, as the item set grows, the model's ability to refine these representations diminishes. Each transformer layer aims to adjust and refine the latent representation, ideally shifting it away from representations of the prompted items. Current architectures, however, lack the necessary depth to perform this refinement effectively for many items, leading to repetitions. Repetition is identified as a critical failure mode in LMS when tasked with missing item prediction. The study highlights that while models can predict relevant items in scenarios like movie recommendations, the growing repetition rate is problematic. This issue frustrates users, especially when they expect diverse and novel recommendations based on extensive input lists. Repetition limits the utility of conversational recommender systems, which rely on the model's ability to generate unique and varied suggestions. The paper explores fine-tuning as a potential solution to the repetition problem. Fine-tuning on numeric items shows some improvement in domain accuracy. However, the benefits do not extend to larger item sets or different domains, indicating a fundamental limitation of current attention mechanisms. Fine-tuning enhances performance within specific contexts, but falls short of addressing the broader issue of attention overflow in diverse applications. The contrastive evaluation provides further insights into the model's capabilities. When explicitly asked if an item is present in a list, the model maintains a higher accuracy, 75% below 1,024 items. This suggests that the model can effectively identify items within a list when directly queried. However, the task becomes significantly harder when the model must infer the missing item from a long list of similar items, highlighting the complexity of context-length stress test testing. Conclusion. The findings from this study have significant implications for the deployment of LMS in practical applications, especially those involving long context inputs. The presence of attention overflow suggests that models may not effectively utilize their theoretically large context windows. This limitation must be acknowledged when designing systems that rely on LMS for tasks like recommendation generation, list completion, and other applications requiring long context processing. The study emphasizes the need for improved attention mechanisms capable of handling large input lists without succumbing to repetition. Current transformer architectures, despite their advancements, exhibit fundamental limitations in this regard. Future research should focus on developing and testing new attention mechanisms or architectural modifications that can better manage long context and mitigate attention overflow. The introduction of a new dataset for missing item prediction and the public availability of this dataset is a significant contribution. This resource will enable further research and experimentation aimed at understanding and addressing the challenges of long context processing in LMS. By providing a standardized benchmark, the study facilitates the development of more robust and capable language models. The study provides evidence for the need to be cautious when interpreting the context-linked capabilities of LMS. While models may theoretically support long contexts, their practical performance can degrade due to attention overflow. This finding underscores the importance of rigorous evaluation and testing to understand the actual capabilities and limitations of language models in handling extensive input lists. The paper opens several avenues for future research. Analyzing the behavior of attention heads during long context tasks could provide deeper insights into the causes of attention overflow. Exploring new architectures or modifications to existing transformer models that can better handle long contexts is another promising direction. Investigating fine-tuning strategies tailored to specific applications could enhance model performance in those contexts. Finally, developing techniques to improve the user experience in recommendation systems by minimizing repetitions and ensuring diverse suggestions is crucial. In summary, this study highlights a critical limitation in current LLMs related to attention overflow during long context tasks. The findings demonstrate that while LMS show promise in missing item prediction and recommendation scenarios, their performance degrades with larger input lists due to repetition issues. This underscores the need for improved attention mechanisms and architectural innovations to fully realize the potential of LMS in handling long context inputs. The introduction of a new dataset and benchmark provides a valuable resource for ongoing and future research aimed at overcoming these challenges. The paper, titled Clay, a Controllable Large-Scale Generative Model for Creating High-Quality 3D Assets, presents a novel approach to generating 3D assets using a large-scale generative model. Introduction. The paper introduces Clay, a 3D geometry and material generator designed to transform human imagination into intricate 3D digital structures effortlessly. The model supports classic text or image inputs and 3D-aware controls from diverse primitives. Clay comprises a multi-resolution variational autoencoder, or VA, and a minimalistic latent diffusion transformer, or DIT, to extract rich 3D priors directly from a diverse range of 3D geometries. Background and motivation. Current 3D creation workflows require immense artistic expertise and manual labor. Existing digital tools are often limited, hampering the potential to craft intricate 3D worlds. The ideal 3D creation tool should convert vibrant imagination into digital reality, crafting geometry and textures effortlessly while supporting diverse controllable strategies for creation. Related work. The paper reviews the current state of the art in 3D asset generation, categorizing them into two main strategies, lifting 2D generation into 3D and embracing 3D native strategies. It discusses the limitations of these approaches, such as the lack of concise 3D controls and the inability to maintain high geometric fidelity. Clay model and architecture. Core components. Multi-resolution VE adopts neural fields to represent continuous and complete surfaces and uses a geometry generative module with pure transformer blocks in latent space. Latent diffusion transformer, or DIT, is a minimalistic structure that accommodates adaptive latent size for efficient training. Training scheme. A progressive training scheme is used to increase both the latent size and model parameters. Clay is trained on an ultra-large 3D model dataset obtained through a carefully designed processing pipeline, resulting in a 3D native geometry generator with 1.5 billion parameters. For appearance generation, Clay produces physically based rendering, or PBR textures, by employing a multi-view material diffusion model that can generate 2K resolution textures. Geometry and texture generation. Clay separates geometry and texture generation processes, employing a VE for efficient geometric data encoding and decoding, and a DIT for probabilistic geometry generation. The model scales up effectively by employing multi-resolution encoding and progressive training schemes. Geometry unification. A standardized geometry remeshing protocol is applied to ensure watertightness while avoiding discarding useful data in the training set. This process preserves essential geometric features such as sharp edges and flat surfaces. Geometry annotation. Precise textual prompts are emphasized in the 3D model to capture geometric and stylistic details of objects. GPT-4V is used for producing detailed annotations, enhancing the model's capability to interpret and generate complex 3D geometries. Material synthesis. The model synthesizes PBR materials, including diffuse, roughness, and metallic textures. A multi-view material diffusion model is developed to synthesize textures efficiently and map them accurately onto geometry's UV space. This results in high-quality textures sufficient for realistic rendering tasks. Model adaptation. Clay supports various conditional modalities, including text, image or sketch, voxel, multi-view images, point cloud, bounding box, and partial point cloud with an extension box. This enables the model to generate 3D content targeted to specific styles and user controls. Conditioning scheme. Additional conditions are integrated as parallel residuals alongside the text condition, allowing for effective integration of various 3D modalities into the model. Implementation. Different conditioning types are implemented by independently training additional cross-attention modules while keeping other parameters fixed. This includes image or sketch conditioning, voxel conditioning, bounding box conditioning, sparse point cloud conditioning, multi-view image conditioning, and partial point cloud with extension box conditioning. Results and evaluations. Model performance. Quantitative evaluations show that larger models outperform smaller ones in text-to-shape generation tasks. Various conditioning modules are assessed using metrics such as chamfer distance, or CD, earth movers distance, or EMD, voxel IU, and F-score. Prompt engineering. Different prompt tags are tested to alter generated content, demonstrating precise control over geometry style and enhancing the quality and specificity of generated shapes. Geometry diversity. The model generates high-quality geometries with rich diversity, accurately reflecting input text or image while introducing novel structural combinations absent from the dataset. Comparison with state-of-the-art. Clay outperforms other state-of-the-art methods in generating high-quality 3D assets quickly and efficiently. It produces smooth surfaces with intricate details, matching text prompts and image inputs more accurately than other techniques. Conclusion. Clay represents a significant advancement in 3D asset generation, combining the strengths of both 2D-based and 3D-based generation approaches. Its architecture and training schemes enable it to produce high-quality, diverse 3D geometries and textures efficiently. This model has the potential to revolutionize the 3D creation workflow, making it accessible to a broader range of users and applications in gaming, film, and virtual simulations. Retrieval-Enhanced Machine Learning Synthesis and Opportunities. Introduction. The paper focuses on Retrieval-Enhanced Machine Learning, or REML, a paradigm aimed at improving language models through the integration of retrieval components. REML addresses several key challenges in natural language processing, such as knowledge grounding, interpretability, and scalability. The authors propose extending REML beyond NLP to fields like computer vision, time series prediction, and computational biology. The goal is to synthesize existing literature with consistent notations, bridging the gap between traditional information retrieval research and modern REML studies, thereby fostering interdisciplinary research. Background. Recent advancements in large language models have been driven by scaling up parameters, leading to significant performance improvements. In-context learning has emerged as a transformative capability, allowing large language models to dynamically adapt and incorporate new information during inference. Concurrently, the information retrieval community has developed techniques to enhance the efficiency and robustness of accessing large-scale information collections. The convergence of these domains has led to the integration of retrieval mechanisms in machine learning models, allowing predictions to be grounded in external knowledge without increasing model capacity. Motivation. Enhancing model performance by increasing parameters is not sustainable. Retrieval-based models offer an alternative by transferring the burden of memorization to external storage systems. Retrieval-augmented methods have shown promise in improving model performance and reducing the need for larger models. Applications of REML. REML can be applied to various subdomains including language modeling, machine translation, question answering, fact verification, dialogue systems, slot filling, state tracking, multimodal dialogue, reinforcement learning, computer vision, common sense reasoning, evidence attribution. Knowledge graph augmentation, ranking, personalization, mathematical problem solving, code generation, representation learning for audio and speech, time series forecasting, and protein structure prediction. Open source frameworks like LangChain, LeMainDex, and DSpy have facilitated the adoption of retrieval-based models, underscoring the versatility of REML across various applications. Main contributions. The paper formalizes the REML framework and synthesizes existing studies with consistent mathematical notations. It also integrates foundational information retrieval research into the design of REML models, enabling researchers across fields to understand and leverage REML effectively. REML framework. REML models learn a functional relationship mapping input space to output space using information access models. The prediction model interacts with one or more information access models to access knowledge repositories. Key requirements for REML models include querying, retrieval and response utilization, with optional properties of storing information and providing feedback. Querying. Querying involves how requests are represented and constructed. Key aspects include deciding where to query, selecting appropriate corpora and retrieval models, formulating the input by transforming the input into a query format through compression, expansion, or conversion, and decomposing the input by breaking down complex inputs into simpler parts for better retrieval. Searching. Different retrieval models handle various types of data, including sparse and dense representations. Retrieval models like TF-IDF BM25 and neural network-based models are used depending on the task. Generative retrieval models and re-ranking models further enhance retrieval performance. Presentation and consumption. Presentation involves transforming retrieval results for consumption by the predictive model. This includes transforming data through decontextualization, translation, or summarization, combining results by summarizing or combining multiple items, and truncating results by optimizing the list of results for length and diversity. Consumption refers to how the predictive model incorporates retrieval results. Methods include single, ensemble, joint, and multi-round consumption, with various consumption algorithms like extractive, analogical, contextual, and latent approaches. Storing. Storage operations in REML include address generation, reading, and writing. Storage can be coupled, meaning updated dynamically during training, or decoupled, meaning read only during online stages. Coupled storage offers benefits like end-to-end training and episodic memory, but faces challenges like staleness and cold start problems. Decoupled storage is easier to implement and avoids these issues, but may lead to suboptimal performance. Optimization. Optimization can be end-to-end or independent for different components of REML systems. Retrieval models are often trained using query document relevance triplets with signals from explicit annotations, implicit feedback, or weak supervision. Optimization approaches include pointwise, pairwise, and listwise ranking. Conclusion. REML presents a promising paradigm for enhancing machine learning models by integrating retrieval components. This framework extends beyond NLP to various machine learning domains, offering a structured approach to leverage external knowledge and improve model performance. By synthesizing existing research and integrating information retrieval methodologies, the paper aims to equip researchers with a comprehensive understanding of REML, fostering interdisciplinary advancements in machine learning. Write a realistic and challenging benchmark for reasoning-intensive retrieval. The paper titled Bright A Realistic and Challenging Benchmark for Reasoning-Intensive Retrieval introduces a new benchmark designed to evaluate the performance of retrieval models on queries that require intensive reasoning rather than just keyword or semantic matching. This is in contrast to existing benchmarks that primarily consist of simpler information-seeking queries where basic retrieval techniques often suffice. The authors identify a gap in current benchmarks and retrieval models, noting that many real-world queries are complex and need deeper understanding and reasoning to identify relevant documents. For example, answering a coding question may require understanding the logic and syntax of the functions involved, which goes beyond surface-level matching. To address this, the authors created Bright Benchmark for Reasoning-Intensive Text, which consists of 1,398 real-world queries from diverse domains such as economics, psychology, robotics, software engineering, and earth sciences. These queries are sourced from naturally occurring or carefully curated human data. The benchmark is designed to test the ability of retrieval models to handle these more complex queries. The evaluation of existing state-of-the-art retrieval models on Bright revealed poor performance, highlighting the benchmark's challenging nature. The best model in the MTEB leaderboard, which achieved a score of 59.0 NDCG at 10 on simpler datasets, only scored 18.0 NDG at 10 on Bright. This significant drop demonstrates the difficulty of reasoning-intensive retrieval tasks. The authors also explored improving performance by augmenting queries with chain-of-thought reasoning generated by large language models LLMs. This approach resulted in performance improvements of up to 12.2 points, showing that LLM-generated reasoning can help in better matching complex queries to relevant documents. Furthermore, Bright was found to be robust against data leakage during pre-training, maintaining similar performance even when benchmark documents were included in the training data. In terms of methodology, Bright includes 12 datasets from diverse domains, each constructed from real-world queries and corresponding relevant documents. The datasets are built from platforms like Stack Exchange, which includes domains such as sustainable living, economics, psychology, robotics, earth sciences, biology, and coding. For each domain, human annotators selected high-quality posts with linked web pages that were used to create query document pairs. Positive documents were passages from these web pages, while hard negative documents were similar in topic but not relevant to the query. Additionally, Bright includes coding datasets that require retrieving syntax documentation or similar solved problems, and theorem-based questions where the task is to retrieve solved problems or theorems using the same techniques. For the coding datasets, the authors used problems from platforms like LeetCode and adapted a dataset for the Pony programming language. For theorem-based questions, they sourced data from high-quality STEM datasets and constructed a corpus for Theoremka and AOP's art of problem solving. Experiments were conducted with 13 retrieval models, ranging from traditional sparse models like BM25 to large dense retrieval models, including open source and proprietary models. The results confirmed the challenging nature of Bright, with the highest score being only 22.1 NDCG at 10. The authors found that current models struggle with reasoning-intensive retrieval, and that new methods are needed to address this challenge. The study also demonstrated that re-ranking with LLMs can enhance retrieval performance. Using reasoning steps generated by LLMs like GPT-4, Llama 370 billion, and others as queries improve the model's performance. This approach highlights the potential of LLMs in augmenting retrieval systems for more complex queries. The authors ensured the robustness of Bright against data leakage by continuing training a model Gretel on the Stack Exchange data from Bright. Despite the exposure to the retrieval pool, the model did not show significant performance improvement, underscoring the need for reasoning capabilities in the retrieval process. Finally, the paper also explored the challenges of long context retrieval, where documents are lengthy and require retrieval models to process more extensive text. Even with a reduced search space, existing models found it difficult to perform well on these tasks, indicating the need for further advancements in handling long context retrieval scenarios. In conclusion, Bright sets a new standard for evaluating retrieval models on reasoning-intensive tasks. It exposes the limitations of current retrieval systems and paves the way for future research to develop more sophisticated and effective retrieval methods capable of handling complex, real-world queries. The authors have made their code and data publicly available, encouraging further exploration and improvement in this field. The paper titled a comparative study on automatic coding of medical letters with explainability. By Jamie Glenn, Lefeng Han, Paul Rayson, and Goran Nenetic focuses on the potential for using natural language processing, NLP, and machine learning ML techniques to automate the coding of medical letters. This study aims to create a prototype that can assist human coders and explore the feasibility of integrating such systems into real-world medical practice. Currently, medical coding is a manual process where professionals review patient documents and assign specific codes to conditions, diseases, procedures, and medications. These codes are essential for maintaining standardized medical records and facilitating the processing and storage of electronic health records, EHRs. The manual coding process is time-consuming and resource-intensive, particularly in large healthcare systems like the NHS in the UK and similar systems in the US. Automatic coding has the potential to streamline this process, reduce workload, and improve efficiency. The paper outlines the use of the Mimic-AI database in the Han network models for ICD code prediction. It also examines the mapping between ICD codes and the SNOME-CT knowledge base. The study highlights that the models provided useful information for 97.98% of codes, indicating significant potential for practical implementation. The background section of the paper is divided into two parts: pre-neural network methods and neural network-based methods. Early attempts at automated medical coding involved rule-based systems and statistical approaches such as logistic regression and support vector machines. These methods, however, struggled with scalability and adaptability to the complex, dynamic nature of medical terminology. With the advent of neural networks, significant advancements were made in automated medical coding. Recurrent neural networks, RNNs, including gated recurrent units, GRUs, and long short-term memory LSTM networks, were employed to handle sequential data in medical texts. However, these models face challenges in handling long sequences and providing interpretable results. Attention mechanisms and transformer-based models, such as BERT and ExcelNet, brought further improvements. These models use self-attention mechanisms to process input sequences in parallel, allowing them to handle longer text more efficiently and provide better performance in code prediction tasks. The introduction of hierarchical label-wise attention networks HLAN and multi-hop label-wise attention transformers MHLAT further enhanced the capability of these models by focusing on the most relevant parts of the text for each code prediction. The study evaluates three models: CAML convolutional attention for multi-label classification, LAN hierarchical label attention network, and MHLAT multi-hop label-wise attention transformer. CAML uses a CNN-based architecture with an attention mechanism, LAN employs bi-GRU layers with label-wise attention, and MHLAT combines ExcelNet with multi-hop label-wise attention. The models were tested on the Mimic-AI and Mimic-AI 50 datasets, showing varying levels of performance in terms of precision, recall, and F1 scores. The Mimic-AI dataset is a large, freely available database comprising de-identified health-related data from over 40,000 patients. It is a relational database with 26 tables, but only 5 tables are relevant for this study: note events, diagnoses_ICD, procedures_ICD, D_ICD_ICD_ICD_ICD_procedures. The dataset's complexity and size present challenges, but it is essential for training and evaluating automated coding models. The study's results indicate that attention-based models, particularly transformer-based ones, offer superior performance and the potential for explainability. The HLAN model, despite slightly lower performance metrics compared to MHLAT, provides enhanced interpretability, making it a preferred choice for clinical settings where transparency is crucial. To implement these models in practice, the study proposes a data processing pipeline that involves pre-processing the text data, training the models, and mapping the predicted ICD codes to SNOME-CT codes. The mappings are essential for integrating the system into existing medical coding standards and ensuring consistency across different coding systems. The paper concludes with a discussion on the future of automated medical coding. It suggests that creating a new dataset that more accurately represents the data encountered in real-world practice could improve model performance and generalizability. Additionally, integrating comprehensive coding standards like SNOME by default in such datasets would eliminate the need for complex mappings. The study highlights the potential of automated medical coding systems to significantly reduce the workload of medical professionals, improve coding accuracy, and enhance the efficiency of healthcare systems. However, it also acknowledges the challenges and limitations, such as the need for large computational resources and the importance of maintaining high ethical standards when dealing with personal healthcare data. The paper CodeV Empowering LLMs for Verilog Generation through Multi-Level Summarization addresses the complexities and high costs associated with modern processor design, emphasizing the necessity for processor design automation. It explores the limitations of existing large language models or LMS, like GPT-3.5 and GPT-4 in generating Verilog code, a hardware description language, or HDL. The authors observe that Verilog code collected from the real world is of higher quality than those generated by LMS, and LMS excel more in summarizing Verilog code rather than generating it. Modern processor design is a complex and costly process, particularly in coding using HDL such as Verilog. Traditional methods like chisel and high-level synthesis, which compile high-level programming languages to Verilog, are not sufficient for the increasing demand for automation in processor design. Recent advancements in LMS have shown promise in automating code generation for general-purpose languages, but have not been as effective for Verilog due to the scarcity of high-quality instruction tuning data. The authors note two significant observations. First, real-world Verilog code is of higher quality compared to LLM-generated code, with fewer syntax errors and clearer semantics. Second, LLMs are more adept at summarizing Verilog code than generating it from scratch. Based on these observations, the authors introduced CodeV, a series of open-source instruction-tuned Verilog generation LLMs. Instead of generating Verilog descriptions and then obtaining the corresponding code from advanced LMS, CodeV reverses this process. It prompts the LLM with Verilog code and has the LLM generate corresponding natural language descriptions through multi-level summarization. The methodology involves several key steps. The first step is the collection of high-quality Verilog code. The authors collected over 1,500,000 Verilog codes from GitHub and filtered them to obtain a deduplicated, self-contained, and syntax-correct set of 165,000 high-quality Verilog modules. The filtering process involved removing files with external references, implementation unrelated comments, and those exceeding a certain length. They also performed syntax checks to ensure the quality of the dataset. The second step is multi-level summarization. Manual annotation of Verilog code is time-consuming and costly. To address this, the authors employed GPT-3.5 to generate high-level summaries for each Verilog module as its requirement description. This involved a multi-level summarization method where GPT-3.5 first generates detailed functional descriptions and then abstracts high-level summaries. This method aims to bridge the semantic gap between high-level requirement descriptions and low-level Verilog code. The third step is data decontamination. To ensure fair evaluation, the training data was decontaminated to remove sequences similar to benchmarks using the Rouge-L similarity metric. Data with Rouge-L scores greater than 0.5 with any of the benchmarks were removed to prevent test data leakage. The fourth step is supervised fine-tuning. The authors fine-tuned base models including CodeLlama, DeepSeek Coder, and CodeQuinn on the high-quality dataset using PyTorch's distributed data parallel on NVIDIA 180GB SMX GPUs. They employed the Add-a-Factor optimizer with a linear learning rate scheduler, setting the initial learning rate at 5e-5 with 15 warm-up steps and a global batch size of 256 with a maximum sequence length of 2048. The experiments demonstrated the CodeV series achieved state-of-the-art results on the Retrieval and RTL-LM benchmarks, significantly outperforming previous open-source and commercial models. The key contributions highlighted in the results are CodeV's method of providing GPT-3.5 with Verilog code to generate high-quality instruction tuning datasets outperforms prior data construction methods for Verilog generation tasks. The CodeV models, particularly CodeV CodeQuinn, achieve superior pass rates in both machine-generated and human-crafted Verilog generation benchmarks compared to previous state-of-the-art models, including GPT-4 and An ablation study was conducted to measure the effectiveness of multi-level summarization. The study showed that instruction data obtained through multi-level summarization significantly enhanced model performance across various metrics. The authors also analyzed the impact of dataset size on model performance. They observed that performance generally improved with larger training set sizes, although returns diminished as the size increased. This suggests that, for models of certain sizes, increasing the quality of the dataset may be more beneficial than simply increasing its size. The paper concludes by presenting CodeV as a significant advancement in Verilog generation, with its novel method of dataset construction and fine-tuning achieving state-of-the-art results. However, the authors acknowledge two main limitations. First, CodeV cannot directly generate complex circuits without a framework. Second, CodeV lacks circuit optimization capabilities. Future work will focus on enhancing the model's performance in real-world applications and addressing these limitations. The authors also plan to open source a series of CodeV models and the instruction tuning dataset to support further research and collaboration in the fields of LLM, electronic design automation, and programming languages. PM-LLM-Benchmark evaluating large language models on process mining tasks. The paper PM-LLM-Benchmark evaluating large language models on process mining tasks explores the potential of large language models LLMs in automating certain aspects of process mining analyses. The authors Alessandro Berti, Humam Karani, and Will MP. Van der Aalst proposed the PM-LLM-Benchmark, a comprehensive benchmark specifically tailored for evaluating LLMs on process mining tasks. This benchmark focuses on domain knowledge and implementation strategies, addressing challenges such as public data availability and evaluation biases. Process mining is a data science discipline that derives insights from event data recorded during process execution. Automated techniques exist for process discovery, conformance checking, and model enhancement. The application of domain knowledge can significantly enhance these techniques. Modern LLMs, like OpenAI's GPT-4, have shown capability in various AI tasks, including semantic anomaly detection and root cause analysis. However, there is a gap in understanding how open-source LLMs compared to commercial models in AI tasks. The benchmark assesses LLMs on two implementation paradigms: direct provision of insights and code generation. It includes categories of prompts requiring process mining-specific and process-specific domain knowledge. The evaluation strategy involves using LLMs as judges to score the quality of textual and coding responses from other LLMs, acknowledging the challenges and biases inherent in such an approach. In their study, the authors present several contributions. 1. A comprehensive benchmark for process mining tasks executable by LLMs. 2. A scalable evaluation strategy using LLMs as judges. 3. Results from applying the benchmark to various state-of-the-art LLMs. The benchmark includes prompts stored in TXT files, focusing on general-purpose qualitative tasks, open-close process mining domain knowledge questions, process model generation and understanding, hypotheses generation, fairness assessment, and visual prompts. The prompts test the LLM's capabilities in interpreting and producing different process mining artifacts, formulating hypotheses, and assessing fairness from event data. The evaluation strategy uses advanced LLMs such as GPT-4 as judges to assign scores to LLM responses. This approach allows for open-ended inquiries and the potential for dynamic improvement in LLM training and evaluation processes. However, the authors caution against directly comparing high-performing LLMs due to potential biases and the need for a more nuanced assessment of LLM capabilities. The results show that commercial and large open-source models generally perform well in process mining tasks, with commercial models like GPT-4 and Claude AI leading the rankings. Small and tiny models, however, struggle with complex tasks. The authors emphasize the need for future benchmarks to incorporate retrieval-augmented generation RAG, agent-based evaluations, hypotheses refinement, and dynamically generated datasets to further advance the field of PM on LLMs. The paper also discusses related work in connecting LLMs to ASHI, including the use of LLMs in process modeling, database query generation, and autonomous hypothesis generation. It highlights existing benchmarks and their limitations, underscoring the novelty and importance of the PM-LLM benchmark. In conclusion, the PM-LLM benchmark represents a significant step forward in evaluating the capabilities of LLMs in process mining. It provides a comprehensive framework for assessing LLM performance, identifying areas for improvement, and guiding future research in integrating LLMs with process mining tasks. The benchmark's findings suggest that while LLMs hold promise for semi-automating analyses, further advancements and refinements are necessary to fully realize their potential in this domain. The paper titled Benchmark Agreement Testing Done Right, a guide for LLM benchmark evaluation discusses the importance of validating the benchmarks used to assess language models LMS. It highlights the lack of standardized procedures for benchmark agreement testing BAT, which can lead to invalid conclusions and mistrust in benchmarks. The authors propose best practices for BAT to improve robustness and validity, introduce a Python package named BenchBench for standardized BAT, and release the BenchBench leaderboard to evaluate benchmarks using their peers. Introduction. Language models have advanced significantly, leading to the creation of multiple benchmarks to assess their capabilities. Validating these benchmarks through BAT is crucial but lacks standardization, leading to potential inconsistencies. That typically involves comparing a new benchmark against established ones using metrics like Pearson correlation. High agreement indicates that the new benchmark measures similar abilities to the established benchmarks, while low agreement suggests it assesses unique traits. Both benchmark creators and consumers rely on BAT to validate and choose benchmarks. Setup. The authors analyzed over 40 benchmarks and 200 models, including AGI Eval, Alpaca, HuggingFace OpenAll Leaderboard, MMLU, and more. They focus on evaluating agreement between a reference benchmark, an established one, and a target benchmark, the new one. Agreement is calculated using rank Kendall or score Pearson correlations. The study emphasizes the importance of having a large set of intersecting models between benchmarks for reliable BAT. Methodological decisions in BAT. 3 critical methodological decisions in BAT significantly impact its results. 1. Choice of reference benchmark. The choice of reference benchmark can lead to varying agreement scores. For example, Alpaca v2 showed different levels of agreement with other benchmarks, depending on the reference benchmark used. The authors suggest using an aggregate reference benchmark, combining multiple benchmarks first to provide a stable basis for comparison. 2. Choice of models. The number and properties of models included in BAT affect the results. Using a small number of models can lead to unreliable conclusions. The authors recommend using at least 10 models representing diverse sizes, architectures, and training methods, and sampling them randomly to ensure unbiased results. 3. Choice of correlation metric and threshold. Different correlation metrics rank VS. Score and thresholds for interpreting agreement scores can lead to different conclusions. The study found a linear relationship between Kendall-Tal and Pearson correlation metrics, suggesting a need for a data-driven approach to interpret correlation scores. BAT best practices. The authors propose the following best practices for reliable BAT. 1. Use an aggregate reference benchmark. Combining multiple benchmarks into an aggregate reference benchmark provides a more stable basis for comparison and reduces variance in BAT results. 2. Use more models and sample them randomly. Using a larger number of models and sampling them randomly ensures more reliable results and reduces variance. 3. Report multiple granularities. Reporting agreement scores at multiple resolutions, e.g., 5, 10, 20 contiguous models provides a nuanced view of benchmark agreement and helps manage expectations of benchmark consumers. 4. Use a data-driven threshold. Interpreting agreement scores using a data-driven approach, such as calculating the z-score of the target reference correlation score, ensures that the notion of agreement is relative to the population of existing benchmarks. Bench, a package and leaderboard. The authors introduced Bench, a Python package implementing the proposed best practices for BAT. It standardizes arbitrary decisions, ensuring reproducibility. Bench allows users to input their BAT configuration, recommends a set of models for evaluation, and produces a full BAT report. The Bench leaderboard ranks benchmarks based on their agreement with a desired group of reference benchmarks, facilitating informed evaluation decisions. BAT uses in related work. The paper elaborates on how BAT has been used in various studies to validate benchmarks and compare models. For example, Louis et al. 2021 used BAT to show high agreement across QA datasets, while Sun et al. 2023 demonstrated disagreement among compositionality benchmarks. Other studies used BAT to validate efficient benchmarks or synthetic benchmarks as proxies for original ones. Discussion and conclusions. The authors emphasize the need for standardized BAT methodology to ensure valid and reliable benchmark evaluations. They highlight the impact of methodological choices on BAT conclusions and propose best practices to improve the process. The Bench package and leaderboard aim to facilitate consistent and reproducible BAT in the research community. Limitations. The authors acknowledge the limitations of their study, such as the reliance on available benchmarks and the potential variability in benchmark agreement due to different model tiers. They call for further research to address these limitations and improve BAT methodologies. In conclusion, the paper provides a comprehensive guide for standardized BAT, emphasizing the importance of methodological consistency and proposing best practices to improve the robustness and validity of benchmark evaluations and language model research. The introduction of the Bench package and leaderboard aims to facilitate consistent BAT and support future research in the field. That wraps up our deep dive into the HuggingFace papers released on July 19th. We hope you found these insights as exciting and enlightening as we did. The innovations and research we've explored today truly showcase the incredible advancements happening in the world of AI. If you enjoyed this video and want to stay updated with the latest in AI and machine learning, don't forget to hit the like button and subscribe to our channel. Your support helps us bring you more in-depth analyses and fascinating discoveries. Also, feel free to leave your thoughts and questions in the comments below. We love hearing from you and engaging in insightful discussions. Thanks for watching, and stay tuned for more cutting-edge content in our next episode. Until then, keep exploring and stay curious.